Hello, I'm Greg Krinklaw, the developer of SkyTools. I'm outside, it's getting dark, and I am ready to observe. Tonight, we're going to explore the real-time tool for visual observing and its various workflows. The real-time tool came about when I realized that the nightly planner did a poor job of telling you which objects to look at when you were already outside under a dark sky. So I decided to create a separate tool dedicated to use at the telescope at the current time, as read from your computer clock. In other words, it would always work in real time. This tool can directly control a GOTO Telescope or a scope connected via digital setting circles. But it's important to remember that you don't need to use either of these. You can think of the real-time tool as an assistant, there to help you decide what to look at right now. Ultimately, this tool is meant for use at the telescope, regardless of how you observe. Remember, other software can make lists of objects and generally tell you what to look at, but SkyTools takes that a big step further to ensure that you always get the best view, or the best chance to detect a challenging object. Sometimes people want to use the real-time tool for other purposes. I'm sometimes asked to be able to sort by columns, for example. Just as you wouldn't use a screwdriver to work on your pipes or a chainsaw to make furniture, it's best to use the appropriate tool for the job. These tutorials will show you the entire workflow and how the different tools are intended to be used together. In the process, the role of the real-time tool will become clear. There are two real-time modes, Best Now and SkyTour, and there are separate sets of workflows for each. The three main ways to use SkyTools in the field are to use on-screen finder charts to find your targets, a GOTO Telescope, or a DSC connected directly to SkyTools. I've created multiple videos depending on which of these methods you use yourself. If you don't use either of the telescope control methods or the finder charts, the real-time tool can still help you find timely things to observe at the telescope. In that case, I suggest watching the tutorials for using a GOTO telescope and adopt a similar workflow for whatever method you use to find things in the sky. The planning process begins before we go out to observe. In my case, it was a few days ago. Our workflow begins with the nightly planner. One of the core principles of SkyTools is to plan your observing in advance. Now what that means is to find some great objects to observe before you go out to the telescope. The idea is to use the tools to find objects that are best observed on the night you plan to go out, and then put those objects in an observing list just for that night. These are the steps that we use the nightly planner and its associated tools for. When you go to use the telescope, the real-time tool tells you which objects in our final list to observe at any given moment. So we start by making a list of objects that are good on that night, and then the real-time tool tells us what time to look at each of them. I'm going to plan for an upcoming night using an 8-inch telescope as an example, and then I'll go out and observe on that night using the real-time tool. Now, if I was doing a special project such as the Herschel 400, I could skip this next step where I use the nightly planner to create a custom list and just load the Herschel 400 list into the real-time tool when our night comes. But when we want to observe a lot of different things, we use the nightly planner to create a custom list for that night. I've set the planner for March 24th, an observing location nearby, an 8-inch telescope, and me. The next thing to do is to set up the weather. Never forget the weather. I can't know exactly what it's going to be that night, but a good estimate would be a temperature of 40 degrees Fahrenheit and a humidity of 45%. I'll set the scene to be good. I'll be going to bed at 1 a.m., so I'll drag the right time slider to 1 a.m. I could also have typed it in here as the to time. I'll also tell it that I won't be set up until 7 p.m. This will tell the planning tools not to plan before or after these times. Remember, planets can be observed in daylight, and sometimes they are higher in the sky then, and better observed. The setup time will keep SkyTools from suggesting anything before we are ready. I'm going to create a new custom observing list via the List Functions menu. I'll call it March 24. The quick way to plan is to use the Nightly Observing List generator. So let's start with that. What this tool will do is to use the location, telescope, and night from the nightly planner. It also considers the time range that I just created. There is or will be a tutorial about using the Nightly Observing List generator that goes into more detail. I'm going to just touch on it here. A good place to start is showpieces. This one's great for a public event where you only want things that are bright and obvious, but it's also a good place to start in general if you want things to observe with little extra effort. For planning for a star party or any other night months in advance, it's best to use this tool close to the actual date you plan to observe so that the comet and supernova information will be fresh. The results are placed into a new list that is automatically created for this location and this night. I'm going to just take all of these. To do that, I'll right-click on the multiple selection column and choose Check All. Then I'll right-click in the column, it doesn't matter which object, and select the custom list I created earlier. This will copy all of the objects over. Now let's run it again, but for the NGC IC objects. I could append these objects to the list that the tool already created for this location and night in order to build on what we already had, but in this case, I'm going to just overwrite it. Once again, I'm going to just copy all of them. Here is the list for March 24th that I've created. It has 49 objects in it. I'll remove the ones that I've already logged. I'll right-click on the log icon and select Check All Log Entries. Then I'll right-click in the checkmark column and select Delete Checked Entries. This brings us down to 35 objects, which is a good number for 5 hours of observing. Now, that's the quick way to do this. But let's look at another way to choose objects for our list. I recommend keeping a special list of objects that you want to observe some clear night in the future. Maybe you see an HST image or read an article and think it might be cool to try to observe the object visually. So you'd add it to your special list. Here is an example list I created called Cool Objects. It's got its own attachments folder where I can keep track of why I wanted to observe them. I need to filter out the ones that aren't good on this night, as well as the ones that are too faint for this scope. So I'll set the filters to best quality only and visible at any difficulty. Looks like our only candidate is the Polar Ring Galaxy, NGC 4650. I'll right-click on it and add it to my custom list. I always want to add whatever telescopic comets are available. We added a couple already via the Nightly Observing List generator, but that tool is designed to give us a sample of really bright objects, not every single one available. So I want to add more. We'll go up to the current lists and open the current comets list. Comets tend to hug the horizon, and you can't necessarily look at them on a better night. So I'll relax the quality filter a bit. I love comets, so I'm just going to add them all. We can do the same for supernovae. Sometimes you may get no results using the best quality and visible at any difficulty filters, and that's okay. It just means that there aren't any visible in your scope that night. Another approach to finding objects is to use one of the pre-made observing lists. I'm going to load the Royal Astronomical Society of Canada's finest NGC list. I'll ensure my filters are set to best quality and visible at any difficulty. I'll also filter out the ones I've already logged. Let's see, the Ghost of Jupiter might be good, but is it large enough in the scope? I'll right-click to view it in the telescope finder chart. I could also press T with the object selected. It looks like it should be fine in my 8mm Radian, which has also been picked as the ideal eyepiece. So I'll check that one. What's this lost galaxy? That should look pretty good. I'll open the object info to learn about it. The catalog notes say it was discovered by William Herschel and that it's pretty faint, very large, and resolvable. Okay, I just did some Googling, and apparently Leland Copeland named it in the 1950s because its faint ghost-like appearance. I'll check it too. Now I could add more, but you get the idea. Use the tools on hand, such as the object info and the charts, to help you decide whether or not to observe an object. I'll add these to my custom list. Lastly, let's add some double stars. I'll load the most beautiful double stars list. For these, I'll add a splittability filter. Let's make it good split or better. I'm not that interested in challenging observations for these. Let's sort by the best time to observe so I can pick a few pairs to look at during twilight. I'll look for a fairly evenly matched pair. This pair looks good. I'll also open a chart. I can't see the separation because of the resolution of the monitor and the size of the stars drawn. So for the eyepiece, I'll select Match Detail. This will give me an idea of how well I can split the pair. It looks like it'll be a good one, so I'll copy Lambda Ori over. Again, I could add more, but you get the idea. Now that we've created the list that we're going to use, let's have a look at the real-time tool. It has two modes. They both work from an observing list. The Best Now mode is more freeform and relaxed, allowing you to observe at any pace and to choose which objects you want to view from its suggested objects that are at their best right now. The Sky Tour is more structured. You make a full plan ahead of time and then more or less stick to it during the night. You can customize the plan, spending more or less time on an object. The advantage of the Sky Tour is efficiency. If you were doing a large observing project, such as the Herschel 400, it can help you maximize the number of objects you can get during the night. It's also a great way to plan for Messier Marathon. The advantage of Best Now is that you can take as long as you want on each object and decide on the fly what to look at. We'll be using Best Now mode. Let's have a look at the list I've been building. Now, it's not time to observe just yet, so the real-time tool isn't ready to show us anything. But I can review the list in the nightly planner. I'm going to observe for about 5 hours or so. Let's assume 10 minutes per object. There are 300 minutes in 5 hours, so that works out to 30 objects. It's a good idea to have more than I can observe, so I think 39 objects seems reasonable. In practice, I may not get to all of them, but that's okay. Better that than to run out. Let's have a quick look at the refresh rates. From the telescope control menu, select Configure Real-Time Refresh Rates. This menu may say telescope control, but it also has a few options that are important even if they're not controlling a telescope with SkyTools. And this is one of them. The real-time tool follows the current time. To do this, it periodically refreshes the telescope status, the data in the observing list, and any charts that are open, to keep everything up to date. This dialog controls how often these things are updated. We'll start with the charts down at the bottom. The sky doesn't move that fast, so it is unnecessary to refresh the charts quickly. Every 2 or even 5 minutes is fine for most purposes. The simulation charts are the overhead sky, naked eye, and finder charts, customized for your telescope or binoculars. The observing list refresh is important. If you have a long list and a slower device, a list refresh may take several seconds or even longer. The list refresh can interrupt what you're doing with the list, so you don't want it to occur too often. On the other hand, when the sky is changing quickly, such as during twilight, you want it to keep up with the sky. A good refresh rate for a list with less than 100 objects is every 90 seconds. Okay, I'm back. It's the early evening and I've set up my scope. I'll be using the real-time tool in Best Now mode with the custom observing list that I created. I've set up my scope and I've aligned the mount on a few very bright stars using the hand controller. I'll enable night vision mode. There's a tutorial on using night vision mode. I'm using a red screen over my laptop, but I'll be using screen capture for this video, so you won't be seeing the added effects of the red screen. I've loaded the custom list I created earlier. The first thing to do is to update the weather. It's going to be 38 degrees Fahrenheit this evening with a relative humidity of 38%. I'll keep the seeing it good for now until I get a good idea what it is after the sky settles down after sunset. I'll set the quality to best only and the visibility to visible at any difficulty. Oh, and double star splitability to good or better. I know I used these settings when I created the list, but in the real-time tool, these filters are applied at the current time. So only those objects that meet these criteria right now will pass the filter. Here's a tip. I'm going to be logging my objects as I go, and I don't want to have to enter the conditions for every one of them. I'll right-click on any random object and select Create Log Entries, plural. This brings up the New Log Defaults dialog, which is used to set defaults for when you want to enter more than one object at a time. For instance, you might want to enter old logs from a paper logbook. But it also works for entering logs on the same night. What I want to do in this case is to type in a default for the weather conditions. I'll put in good seeing, good transparency, and a few high clouds near the horizon at sunset. And I need to be sure to save them. It's still twilight out, so it's not showing us any objects yet. So let's take a moment to set things up. I'll start with the columns. I'll click the gear icon. I want the ideal eyepiece. I have some double stars, so I'll make sure the star pair data and splitability columns are enabled. I don't need the priority or attachment columns. I don't care about the rise, transit, or set, but the optimum window is good. I don't really see the point in displaying the coordinates. Air mass might be good. For real time, it is very important that the observation status column be enabled. And the separation between the current telescope position is also useful. We don't need the download number because we aren't using a DSC. I'll save this configuration. Let's have a quick look at the telescope control menu. Most of these options control the telescope, but there are a few general ones as well. I'll use this to close the connection when I'm done. These are all described in the help for the real-time tool. The motion controls may be useful for some people. This is like an on-screen hand controller. These buttons move the scope to the north, south, east, and west. North and south are flipped if this button is enabled. There are multiple selections for movement rates. This is 4 times the sidereal rate, 8 times, 16 degrees per second, etc. You can configure these rates via this button. If your mount supports it, you can enter manual tracking rates here. Type the rate in degrees per second and click Run. You could use this for a comet, minor planet, or Earth satellite in order to keep it centered. The SkyTools Object Info can tell you the rates for a comet or asteroid. Because of twilight, it's only suggesting double stars. Recall that I added this particular double in order to observe in twilight. Obviously, double stars aren't as affected by the bright twilight. Planets would also be available if there were any up now. It's now 7:54, and Betelgeuse and Rigel are out. I can also see Aldebaran. I'm going to slew the scope to Lambda Ori. I can right-click on it and select Slew Scope 2, or select it and press F3.
The telescope is slewing.
And it's arrived.
Viewing Lambda Ori.
I'll go have a look at the eyepiece. By the way, if I need to spot a small or faint target in the eyepiece, or maybe determine where I'm pointing if the mount is too far off, I can open a finder chart for this telescope by right-clicking on the object and selecting the telescope. or selecting the object and pressing the T key. This is a two-view finder chart that shows the naked eye view on the left and the eyepiece view on the right. This chart may be different for your telescope depending on your finding devices. If you have a magnifying finder, then you may have up to 3. The flashing crosshair is the current position of the scope, as reported by the mount. For this scope, I usually only really need the eyepiece view, so I'm going to set it to single view and select the eyepiece view. This circle is the field of view of the eyepiece. The arrow is the west, or the direction that the stars will drift if you turn off the drive. Notice that the finder chart automatically opens with the real-time update enabled, so it will update to show the current view as it gets darker. If the telescope doesn't have our star exactly centered, like maybe it's over here, I can update the pointing model for the mount by first centering the target in the eyepiece and then right-clicking and selecting Sync Telescope or pressing the spacebar. Doing this often should keep the telescope pointing accurately throughout the night. So let's say I was looking for a small or faint object that wasn't obvious in the eyepiece. What I can do is to push the scope a bit towards the west while I'm looking in the eyepiece and note the direction that the telescope moves. Then I can return to the chart on the screen and grab the circle where the arrow meets the field of view and holding the mouse button down, drag it to match the orientation in the eyepiece. If I do this right, the orientation of these stars on the chart should match the orientation in the telescope. And that makes it very easy to pick out the patterns so I can look in the right place for a difficult target. It's really useful to have a way to keep track of which objects we have already seen. One thing we could do is to log each object as we go in SkyTools, and then set it to only show objects that haven't been logged. Let's start by setting the log defaults by right-clicking and selecting Create Log Entries, plural. I'll make sure the defaults are for the scope I'm using, the right location, and date. And I'll also enter the weather, so I won't have to do it every time. I'll save and close. Then I can right-click on the object and select Create Quick Log Entry. All I have to do then is type in my notes and click Close. If I set the filter to unlogged, then it will hide each object as I log it. But the problem with this approach is that if I previously logged the object, I'm never going to see it in the list. It's going to be filtered out before I even start based on the previous log entry. A better approach is to use the observation status. If I right-click in that status column, I can set the status to observed, reobserved, not yet observed, or no value. The last two are functionally the same. I'll set it to observed. If I right-click at the top of the status column, I can see the display options. It will only show objects in the list with each status that is checked. If I click on Show Observed, then the check is cleared. The ones marked as observed are filtered out of the list. You can see that Lambda Ori has in fact disappeared. So what you could do is set each object as observed as you observe them, and that will eliminate the clutter of objects that you've already seen. By the way, I can also highlight the object and press Alt F5 to set it as observed. The other thing to be aware of is that the observation status only affects this one observing list and only in the real-time tool. But what if some of the objects had already been set to observed status? Maybe because you used the same list before. Well, you can reset the status of every object from the List Functions menu. Select Reset All Objects to Unobserved Status. I do this every time before I start observing. But there is an even better way. SkyTools can keep track of which objects you have observed for you automatically. Click on the Telescope Control menu and select Automatically Mark Objects as Observed. Doing this will set things up to hide objects that are marked as observed in the status column. And every time you slew to a new object, the last one will automatically be marked as observed and hidden from the list. Let's observe some objects to see how this works. Okay, time has passed and it's 9 p.m. and fully dark. The filters are set to best quality only and visible any difficulty, which I recommend. The only time I'd relax these filters is if I wanted to look at a comet near the horizon, one that never achieves better quality than fair. I might also sometimes change the difficulty filter to exclude difficult objects, or perhaps only display challenges. I'm going to select a new object to observe right now. The ones that are currently best to observe are listed at the top. SkyTools will prioritize objects that are setting soon because the view will not be as good later on and they may no longer even be available. I'll select the top object, which is the trapezium. That's the cluster at the heart of the Orion Nebula. The red dashed line is the altitude and the green vertical line is the current time. See how the trapezium is setting? Have a look at the time left column. This is how much time is left before the object is no longer well observed. Notice that the top objects have less time left than the ones further down. This is SkyTools prioritizing objects that are setting. Looking further down the list, they are setting as well, they just aren't setting as soon. Let's have a look at the bottom of the list. This is NGC 3631. It can be observed for a long time, and looking at the night bar, we can see that it's still rising. While it is already offering a high-quality view, it will only get higher, so it's best to wait. This is why it's sorted to the bottom. Reminder, this list is constantly being updated. If you left it here for an hour and came back, there would be a different set of objects. That's why it's called Best Now mode. Okay, next let's see what happens if I assign a priority to an object. I'll enable the priority column. This is the priority column here. I'll right-click in the column next to the comet 19P Borrelli and change the priority to high. You can see it jumps to the top. If you assign high priorities to objects that you definitely want to observe, it will place them above most others. What this generally means is that you will likely observe it as soon as it passes the filters. You could also assign a low priority, which means you won't see the object near the top of the list until other objects have already been seen. I'm going to select all the objects and plot them on an overhead sky chart. I'll right-click and select Check All. Then I'll right-click on any object in the checkmark column and select View in Overhead Sky for all checked entries. You can see that most of our objects are naturally in the Milky Way, but other than that, they're scattered all over the sky. The objects near the top of the list are in the west, where everything is setting. I don't have to start with the top object, but it's a good idea to select one near the top. Let's observe M79. I'll select it and slew the telescope by pressing F3.
Last
You
target
can
marked
see
is
that
observed.
it's pretty low on the horizon
telescope is
and
slewing.
setting, so it's a good thing I'm getting it now. I'll go have a look in the scope with my wide field
Viewing
finding eyepiece
M79.
inserted. Then it was spot on. I only had to center a little. I'll sync the mount again by pressing the space bar. After taking it in for a while, I switched to my 8mm Radian for a closer view, which was quite nice. Now I'm feeling like a comet, so I'm going to get 19P next. I'll right-click on 19P and select Slew Scope 2.
Last target marked as observed. The telescope is
It
slewing.
marked M79 as observed and starts the scope slewing. As you can see,
Viewing
M79
19P Borrelli.
is gone from the list. If you don't hear the voice, be sure it's turned on. There should be a check next to Speak Telescope Status on the telescope control menu. By the way, I'm wearing an eye patch on my observing eye. Even with night vision mode and a red screen, I can't look at the screen and keep my dark adaptation perfect. So I keep the patch over my right eye and flip it up only when I'm looking in the eyepiece. If you want the best possible view, this is how to do it. I placed the finding eyepiece back in the scope and the comet was obvious. So now that SkyTools knows that we are looking at 19P, let's see how it is organizing the list. I'll clear all of the selections and select the next 5 objects. The next object it is suggesting is NGC 366, and this is because it is setting soon. If we were looking higher in the sky, it would have selected a nearby object instead, probably NGC 1220, and then after that it would move to these objects down here. The effect is to slowly move the scope to the east until you are looking higher overhead and to minimize movement between objects as much as possible. And there is even a better way to do this. I'm going to press the Enter key.
Last target
When I
marked
do
as
that, it
observed.
will automatically
The
mark
telescope is
19p as observed and then slew to the object at the top of the
Viewing in
list.
GC 1220.
If I press Enter again, it slews to
Last
the next
target marked
object.
as observed.
In this
The
mode,
telescope
I
is
am
slewing.
accepting the recommendation for the best object to look at right now.
Viewing IC 1848.
This is the way I recommend observing. Slew to the object, take as much time as you want to, and press Enter when you want to move on. Doing it this way greatly reduces fumbling with the computer. It turns observing into a one-key press operation. To use the Enter key, either the SkyTools chart window or the planner must have the keyboard focus. That means that they have to be selected on your screen. If you have other windows open, return to the planner or the chart window by clicking at the top before pressing Enter. By the way, don't forget that you can open the object info for your target object to read about it. In the dark, I like to have the voice enabled to read it to me. To enable the voice, click Speech and check the box at the top. You can also decide what information is spoken via these controls. If you find it droning on and on, rather than turn it off completely, customize it to only speak what you're interested in. I only want the basic info, catalog data, and my notes. There are several ways to open the object info. From the planner, right-click on the object or press the I key. From the chart, pass the cursor over an object such that it turns blue and displays the basic info on the bottom left, and press the Insert key. Or right-click on the target at the top and select Object Info. One final tip before I get back to observing. If you find the SkyTools voice to be too loud, you can lower the volume on your computer. But you can also lower the volume only for the sounds from SkyTools if you still want to hear other things at a higher volume. To do that, right-click on the volume icon and select Open Volume Mixer. Look for SkyTools. In this case, the chart is open, so it shows the SkyTools chart. Lower this volume, and it will only affect sounds from SkyTools. Well, I'm going to get back to it now. If you have any questions, please feel free to ask on the SkyTools Visual Discussion Forum of the Skyhound Forums. I and others are standing by. Clear skies, and thanks for watching.